I think we can go ahead and get started as maybe other people filter in. So we're just right now just doing a quick chat introduction to save ourselves a little bit of time on and ability to have discussions afterwards. So I want to start out just by thanking everybody for registering and attending today's kind of office hours. This is a thing that we just wanted to try to do primarily because we've had a lot of recent developments over probably the past 6 months, or basically since we went to microscopy and microanalysis. We thought we'd just get everybody kind of collected together, show some new results or new features that we have, start to kind of form a community or a working group, and then get feedback from you guys about maybe things that we can add in or change or evolve in both the system and just the community itself as part of that. And if you see, we actually have a nice, I think, spread of different people from every level, from the graduate student up to research staff at national laboratories, industry, as well as the university. So hopefully we can also learn from each other as part of that. But without too much further ado, so I'm Kevin Field. I'm just going to try to help coordinate today's discussions and kind of cover a couple slides that we have. We have about 2 or 3 demos that we want to get through and then go through just an open discussion. So I will be the ringmaster for the day. And then Chris Field, who's our president for Thea Scientific, will be driving the bus and also showing the demos because he made most of the features. So if he can't do it, no one can as part of the system. So let's go ahead and get into it. And also, please, if you have any questions as we're going through it, feel free to either type it in the chat or just unmute yourself and ask a question. We're happy to answer any of those as they come in on the fly as part of that. And so today's demos and discussions, we're going to be talking primarily, or basically showing primarily the work on the Theoscope S. That's why we're showing it. That's that half shoebox little device that we have on the left. Just as a reminder, that is a GPU embedded computer system that allows you to run the Theoscope software, and the Theoscope describes both the hardware and the software as part of that. We know other facilities like University of Michigan has a Theoscope X system with the capacity for operating Theoscope M. Those are more hardy computing systems, but we're going to show just the Theoscope S versions, but the software or the interface that you're going to see is basically all the same. It's just compute power in the background for today. So if we go to the next slide. So what we wanted to do to start off with is there's a lot of new features in the latest version of the Theoscope software. And so we wanted to highlight 3 primary new features that came into the latest 8.0 version. So we're on the 8th version, if you didn't know that, as the primary one. We push updates about every 2 weeks. And so the 3 that have come in recently, and these actually, many of these have come in from feedback from other users throughout the user group for Thea Scientific. The 3 that we're going to talk about is groups and favorites, side-by-side comparisons, and tiling for small object detection as part of that. So that's what we're going to do. We aren't going to cover how to, say, upload a new image or upload weight files and do that type of stuff. Just for the sake of time, we just want to show the new stuff. But if there's anything that anything that you want to see, we're happy to do that. We're reserving about a half hour at the end here just for discussion and more show and tell as part of that. So if we go, I think we can go right into the quick demo to show the features. So we're going to show some best practices and some new features. So Chris is going to pull in the Theoscope interface here. So this is the common Theoscope interface. This is some research work of actually Justin Hamill, who just joined us. So you can thank him for taking the TEM images as part of this. But this highlights the 3 new features that are in 8.2 that have been instituted. So these were literally, I just think, released last Friday or the Friday before as part of that. And what you're seeing is on the left and on the right is the same image, but 2 different applications of the same machine learning weight file or the same model. So on the left is an image with tiling, and on the right is an image with no tiling in the inference pipeline. And so you can see that there's a distinct difference. So the left side, we're seeing all the cavities, so all these little white dots that Justin wants to count, not by hand, but by using machine learning. We're seeing all of those being segmented in the actual image. And on the right, you're seeing some of those cavities not being segmented at all. And this is the same machine learning model. So this is the same weight file trained in the same data sets, all of this type of stuff as part of that. And the only difference is the left side, we're using our new tiling feature. So some of you may have seen this as being called Asahi, which is, I can't remember the acronym, but basically it's a slicing thing where it'll take the left image and it will, or it takes the image and then it cuts it into smaller boxes, runs inferences on those smaller images, and then aggregates everything together. And so this is something that's really helpful for microscopists, because what we've found in just the past couple of weeks applying this to a bunch of different data sets that we have available to us, that it really is improving small feature detection. So if you guys are looking at small features in different images, or the inverse to think about this is if you have really big images, 4K, 8K, 12K images, this can slice your images down into smaller versions that are able to run on the Theoscope as software. So we're seeing a really significant improvement in that small feature detection. If you notice on the right side where there's no tiling, we're only capturing the qualitatively bigger ones as part of this, where on the left side with the tiling, we're actually capturing the small ones as part of that. So I want to pass it over basically to Chris to show how you would instigate the tiling capability, but then also how to do this grouping. So this is the same model just grouped in two different inference modes. And so you can actually boot up and run both of these at the same time. And then also how to set these as safe favorites. So if Justin wanted to run this, I know he has an in situ anneal that was supposed to be scheduled, but we're going to delay it a little bit. But if he wanted to run the same model in 2 weeks, how he would favorite it and be able to run this for the next experiment, and then for the next week, so on and so forth. So that's just a quick overview of the things, but we want to show how to enable those. So Chris, if you want to take it over and go to home.
Yeah, thank you, Kevin. So we have our classic home dashboard. We're not going to spend too much time on here. We're going to assume everybody knows how this works. But this is our main entry point into the application. What we were looking at earlier is what we call the examine dashboard. And so how do we get to where we were at? And what Kevin was showing. Well, first off, we have these favorites, and they're listed up here. We're going to spend most of our time in this, what we call the model management window or panel, and we have our favorites. And we can make any model that we would spin up, any weight file we want, a favorite. So I've already preloaded some favorites in here that are kind of our go-to ones that we've been playing around with or that we are using on a day-to-day basis. And so you can see we have, for example, this University of Michigan cavities no tiling and the University of Michigan's with tiling. So if we were going to add tiling to a system, right now it needs to be a YOLO model. It needs to be a V8 and or a V11 model. And the V11s were just released a month ago. So we do have support for V11s. But we come down here, and this is our start model actor. We come all the way down to the bottom. Yes, you can collapse these so you don't have to scroll that much down here. And we've now have this section called tiling. And as Kevin mentioned, we have two different variants that we've actually implemented. There's the Sahi, which is sort of the normal classic one that's been around since YOLO V5 and been applied to a lot of different models. We just only have support for V8 and V11 at the moment as we're just rolling this out. But then we also have this patch one, which is a newer one. It's like specifically for instance segmentation. Which is something that microscopists we have learned really want as opposed to just bounding boxes. So you can enable it. There's a variety of parameters. You have different parameters for each of the different types of tilers. But you can see here that we're not going to go through all of these different ones. We could spend an entire day talking about these and playing with these, but we do offer all of them. And normally you can just click save to favorites, and then that would make this model in this list here. The other thing that we've done to run multi-model in this case is we also have these two, and we're using fractional GPU usage. So we're using only 50% of our GPU. And we're able to do that because we now have some feedback for everybody about how much of the GPU memory you're using when you spin up a model. And we know from work with Argonne National Lab and Los Alamos National Lab a couple of months ago at their IVM facility, we were able to spin up, I think, like 5 different models on one GPU. So that was pretty cool. And we really thank them for letting us join us and joining them in their experimentation and doing that, because that enables anybody with a Theoscope S and with the single model implementation or a single GPU to run multiple models. So what we can do once they're a favorite is we can go in and we can click the check marks next to them, and we could start up all of the models with all of them that are checked, any of the favorites, and that would spin up all those models in one shot. But what we've also done is we've added in grouping. And the grouping allows you to create groups. I mean, that's pretty obvious, but what we've done is I've created some groups here just to kind of demo this a little bit, but we can create this Cavi tiling side-by-side group, and I added my 2 there. You can have multiple models in multiple groups, so that's great. You can have the one model in multiple groups. And once you group them together, you then can filter by all these groups. So it'll show me everything that's in the side-by-side. I can select all of them. I can hit start, and all of the models in that group will spin up, assuming you have all the correct resources and everything else running. And what this allows you to do is to start creating sort of your experimental parameters. If there's a series of models that you run all the time for an in situ experiment or for a particular sample or for a particular analysis system, you can group them together into this and then spin them all up. And you don't have to go in and click every single model and spin them all up every single time. So you're able to create that, and then you're able to go and you could say, all right, let's do an analysis of all the models. And we have a multi-model dashboard, and there's an acquisition. And we can go pretty quickly with this one, doing a very simple one just to kind of show it off a little bit, because that's what we're here for. Again, trying to get back to that models that we were showing earlier. So I just dragged and dropped an image, I uploaded it, and we're going to see here in just a moment that it's all going to upload, and we can go here. We say no tiling, what did that look like? With tiling, what did that look like? Right, and there we go. There's our side-by-side, and we're ready to go, and we're off to the races and getting that analysis. Now, this is an acquisition that's being done in real time. The other thing that we can also do, and that was highlighted earlier by Kevin, is that we can create and we can share reference images. And the reason for this is that we had a variety of users that wanted to have an image saved and they wanted to compare it during a long run. Right, so they wanted to be able to look at something and say, okay, what does this look like in real time while I'm analyzing an image? So here I can just upload an image and it will give me that image and what it looks like from the beginning. So you get this sort of side-by-side reference comparison, and you can use any image as if you had done inference on it. There's, of course, always a bug, so there's a slight issue in that I got to turn off all the displays here, and then it will look like the way we want it to look. No demo is complete without at least one bug, right? So we've got then our side-by-side and now reference images, and you can start to think about this like you take a reference of the one image at the very beginning of your run, and then you want to compare that later on. The other thing you can do is if you're doing a stream of images or a video, we can bookmark that. So I can say, okay, I'm going to add this one to my bookmarks. And then when I go back to my examine page, and I go back and I look at them later, you can see that we have some images here, and I can go here. Oops. We will have our bookmarks, and they will be listed on here. There's this little bracket, and you can jump straight to that bookmark. So that's how we're able to look at the reference images and do a side-by-side. And I clicked on the wrong dashboard. So what we can do is go back, and we've got the multi-model. If we can play the video game of clicking the right button, we've got that side-by-side comparison, and we can click the no tiling one. And now we're back to where we were at the very beginning. And we can see that we had the one bookmark. We only have one image. So there's nothing to really scroll through in all that case. But we're able to bookmark, we're able to group, we're able to put those favorites together and start them all up in one shot. And we can do this for all the different parameters that are in tiling, no tiling for the model. You could have different YOLO models, you could have different versions of YOLO models, you could have mask RCNN models, all running simultaneously, grouping them together and starting and stopping various analyses. I'm going to hand it back over to Kevin to kind of highlight how we got to this point from and what we have learned working with some of our collaborators and others on these various projects.
Yeah, so that was a quick run through of the features. If there's any questions right now, or if there's some of the new features, if there's any questions right now, I'm happy to answer those, or we can go into the next one just talking briefly about some of the model development that we've been doing.
I have a question.
Yeah, go ahead.
So the tiling, is it like adaptive in that it's several different sizes of the image and then you sort of figure it out? I don't actually know how it works. Like, is it a percent of the image and then you go across it like a fixed size, or is it changing?
Yeah, it's a fixed size. What they basically do, the two that we have implemented, and we've thought about sort of various sizing ones or other ones. There's other tilers out there, but they're actually not that sophisticated. They're just going through and they're chopping up the image. They have a certain percentage of overlap
Okay.
on them, and they use that overlap to determine if that object is sort of in two places at once and remove the duplicates. So, and you can adjust that overlap anywhere from 0, so you have them side by side, all the way up to 100% overlap, which I mean, the more overlap you have, the longer it takes to do the inference for.
Okay, cool. Thank you.
Yep. Yeah, we found it that it's really helpful for post inference because basically if you slice an image up 4 times, then you have to infer 4 times, so you will slow down your overall live feed as part of that. And so that's the nice thing about being able to re-examine the data is that you can re-examine it and then try different slicer versions if you want to and see the value of it. Cool. Any other questions? Okay. So yeah, so one of the things, right, that enabled that ability recently for doing some of Justin's work was that we were able to train and migrate some of the data that we had from a YOLO v5 version, which now is considered old, to the newer versions of V8. And just as to remember, we support V5, V8, all the way up to V11 as the current variant as part of that. But the thing that I wanted to highlight is some more recent work that we've also been doing with Columbia University in transitioning from a UNet-based model into a YOLO V8 plus model for improvement segmentation and tracking. So we really wanted to be able to get to the point of being able to do tracking, and the newer variants of YOLO are much better as part of that. So we see this as a real great success story about collaborating back and forth, and we're still developing it as we go, but we kind of thought it would also show a new use case that we haven't shown to the community before, because it's almost all nuclear materials people besides Columbia and Andrew on the call. So we wanted to show a separate use case as part of that. And so if we go to the next slide. As a former researchers ourselves, and Chris and me still as a researcher, we like to read papers. And so this paper came out in Microscopy and Microanalysis in 2023 from Matthew. So it's a really great paper. You should read it. And we were reading through it and we were like, oh, this is awesome work and an awesome use case. But one of the things is if you look at figure 4, his model is really great, highly accurate, works really well, and the UNet is able to do basically this grain segmentation or basically fine grain boundaries as part of that. And so it works, but if you look at 4, there's a lot of post-processing that goes on the back end of the workflow in order to make it get to the point that they want to use the data as part of that. And so we came to them and we thought, hey, YOLO versions that we just showed for the cavities might be able to eliminate some of that post-processing as part of that. We said, hey, would you be willing to work with us? They said graciously yes. I don't think that you guys knew what you're getting yourselves into, but they said yes as part of that. And so we really set out a goal to try to do to get the same accuracy with a new model, but improve the efficiency, because the UNet works really good, but on our systems, particularly the Theoscope S, it wouldn't be able to run in real time. And really the ultimate use case for the Theoscope is to do real-time inference on the microscope, or real-time like types of ones. And so we wanted to improve the efficiency, or basically get down to grain segmentations that are below a second, so you could do, say, a real-time grain growth experiment as part of that. And the other thing that we really wanted to get to was be able to have each of those grains, or each of the grain boundary segments, be tracked over the duration, because then that ties towards all of these use cases around grain growth and other stuff. And so it also, I was like super excited about it, because it fulfills my love of material science. Like you learn in Material Science 101, grain growth, right, is one of these things. So I was like, yes, we get to do one of those as part of that. And so we wanted to develop that total thing, but there's a real challenge that we have found, and I think a lot of my students, two of them who are on the call, have also found, is that there's a lot of issues with the current workflows around training new models in YOLO. So you can go off and pick it off, and you can get a reasonable model that works, but you're not going to get the accuracy that Matthew was able to get with UNet if you just use out-of-the-box training, particularly when we talk about segmentation masks. So the YOLO versions has an issue with the way that they do segmentation masks, because we have the in-house training ability, and also the ability to go in and do deep dives into the code bases for these different YOLO variants. We're actually able to change that segmentation capability in YOLO and do that as part of that. And then also you can imagine that the YOLO variants is all really supported by Ultralytics, which is another company that supports them, but they provide them for free use as part of that. They're constantly changing their database. And so sometimes you may have a use case where you just want a model, but you don't want to learn all the intricacies of Ultralytics, which is, it's actually extensive as part of that. You can see this is what I pulled from 5:30 this morning. They updated at 4:40 this morning some of their code repository as part of that in there. And so it's constantly changing. And so if you want to take an old model and transition it to a new model, but you don't want to become this expert, that's where we kind of jumped in and helped out and do that. So we built a whole new code basis around training for segmentation masks, and built in some new features, including binary visualization, in order to help with that workflow. And so with that, I'll just pass off Chris to show how that type of collaborative thing. So I think Chris has trained now over like 100 different models as part of this, and overwhelmed everybody for it. But we just want to show where this advantage comes from, and how this use case might be interesting for other people. So I'll pass it off to you, Chris.
Yeah. Thank you, Kevin. Let me see if I can pull up back to our Theoscope S on this. And we can see that we have our models that have already been spun up, and we're going to spin them down so that we can move on and try a different model. So as Kevin was mentioning, we've done a lot of work, and we've learned a massive amount when it comes to this model development part, and all of these different sort of small, minute details that's involved in this whole process of creating models, especially with the YOLO models. And we really do like the YOLO models because they are fast to train. As Kevin mentioned, I have trained a bunch now, and and you can train them. And the V11s, which are now available, we don't have a V11 model ready yet, but the V11 models are even faster to train. So it's this nice sort of progression that we're able to keep up, but we also have to keep up with our model training and learning how all we're going to do that. So I'm going to start this model just as kind of a teaser and to show what we've been working on in this sort of use case, and also kind of walk through the normal workflow again, right? So you start with the running model, you spin it up, you get to your acquisition. We're going to upload an image, but we do have the ability to use the camera or a screenshot or a screen share. We'll upload this, and then we just run it. And the first one is always a little bit slower, but what is really cool and what really started all of this work with us is this is what we did with just a model that I trained for like a 10 minutes and was like, hey, look at how great this is. And then we showed it to Columbia and we're like, let's do something about this. And what we see here is that we're getting the instant segmentation. And what you normally get from a UNet is you get the binary representation. So there's all that post-processing to sort of make sure that you get all of this to happen. And one of the things that has come out of this wonderful collaboration is that we've added in these features to make it easier to do these comparisons and these analyses. And we've also added in a variety of ways to visualize these things. And you get all of this sort of information that you would want from that. And you saw earlier, we have our ability to sort of add in the ways we want to represent the different things in our panel, right? So we're able to do this, and anything that we do here, we're also ultimately able to do in the Examine dashboard. And I'm forgetting why we need to go to the Examine dashboard.
Oh, we just segmentation,
yeah.
instance.
Yeah. We wanted to show the instances. Yeah, there we go. So once you get the instances, what's really great about the instance segmentation as opposed to like these mass segmentations is we can start to get individual information as it's related to each object in the image. And that's when it really starts to sort of click for us in this case. So we can go down here. Which one is number 6? Oh, that's highlighted. That's that one there. Number 6 has a certain size associated with it. We get our size distributions. We get all of this other information. But now we're able to do instant segmentation. And this is another reason to move from not necessarily to move from, but to utilize a YOLO in the future if you're interested in it. We get this faster training time. We can prototype very much more quickly, but we also get this instant segmentation. Now, the instant segmentation comes at a cost in the sense that it's bounding boxes are still the primary driver for YOLO because they're about sort of real-time analysis and real-time object identification. So one of the things that we found is there were some bugs in their software when it came to instant segmentation. And so that has been a thing that we've been working on and trying to find out and make that all happen. So we don't want to bore everyone too much with me clicking. And that is about the 30-minute mark. So we want to move into the discussion. And Kevin.
Yeah. So first off, if you're interested more about the work with Columbia, we're working on a paper with them. So stay tuned. We'll have that out in the near future as part of that. Same thing with Justin's work. Him and I are going to hammer out a paper over the holidays as well. So we'll have that one out. So feel free to do that as part of that. But that's just some of the things that we wanted to show, some new use cases, some reasons that maybe you might want to consider collaborating with us for model development, and then some of the new features. And now we'd like to hear from you guys, or if you have any, first off, any questions, but then we also wanted to see if there's any features that might be interesting that you haven't seen that you want us to integrate, or any of these other kind of points. So we'll just open the floor for discussion.
Hey, Chris and Kevin.
Hey.
Very nice. Very interesting to see the new update. I was just wondering, are you guys considering about like adding the part of training in the software? For example, if I upload the images and I say I want to do YOLO V11 and I start training, and even add the annotation functionality there. So I don't know if it's being considered.
Oh yeah, that is the number one requested feature is onboard training, so that you basically a full integration between your annotation process and then ultimately yielding a model that you can run for your experiments and stuff. And right now, our training pipeline and all this information and all these little details that we've learned has been embodied and handled in a very low-level internal tool. It's basically a command line script that we are, and our goal is to transition that onto a Theoscope platform for training. But one of the things that we want to do, and we do have a proposal. It's been funded. We are working with INL, that's Idaho National Lab, to add in adaptive learning, which is if you had one of the larger systems with multiple GPUs, or you had a cluster of our systems, you would have one running the inference, the other one's running training, and they would automatically push the updated image while you're running at the microscope to that inference image to run inference at the microscope. The other thing that we also have done is we have started partnering with another company to provide much better annotation software and to integrate that onto the system in an onboard way. So it's in the works, and it is definitely something that has been requested multiple times and enough times to do that. I understand, like you look at the inference, you saw I did some clicking, but it wasn't that much clicking, and I got some results. Training is not as polished, right? It's a little bit more work when it comes to that. So, and we're very much aware of that workflow and trying to make that happen.
Okay, yeah, thanks.
Yeah.
I have a question that sort of leads off of that. Have you considered, I mean, there's a sort of a wide range of microscopy problems, right? And image processing problems. Looking at sort of taking foundation models and implementing them and then doing fine tuning on them, something where you don't have to necessarily have a tailored approach for every application, or what does that look like for you going in there?
Yeah, Kevin, I mean, you can jump in and if you want. It's an excellent question because we we originally started off being like, there's never going to be one model to rule them all, right? In that we were sort of like, oh, look at how specific everything has to be to get them to work. It's still better than like thresholding, or it's still more adaptable and flexible in that regard. But what we're kind of learning is that a black dot is a black dot. And so we can kind of just use it. There might actually be one big model, and maybe we just need a microscopy specific foundational model. And there might be enough there to make that happen. That requires coordination, and it requires, I think, data sharing and again, some logistics that the people on this office hours we would love to see some collaboration among everybody here to maybe make that foundational model. And because right now we're just using the pre-training, right?
Yeah, I will add in that we do support Segment Anything version 1 and 2 out of the box. So that's provided and already supported. We have found, like on your guys' image sets on the grains and other kind of ones, it actually works pretty well, right? In certain cases. And in certain cases, it fails completely, right? And
Yeah, I've
it's
played with Segment Anything, and what it does is it finds some of the grains, and then it will find one giant grain everywhere else.
Yep, exactly.
Yep.
And
Yeah.
so we've played around with that a little bit in certain cases, and so that's why the multi-model is really nice, because you could spin up, say, the Segment Anything, and you could spin up the new V8 model and run them together and kind of just see comparisons against them, right? But one thing that we've also seen in some of the research is we've started to take the YOLO model and do training on the decoder and encoder that's in that Segment Anything, and people have done this in research. You can see it, right, where they basically take the existing one and try to train it towards a specific, say, medical image or something like that. In the particular project that I've been working on in that regard, we actually find that you're not getting that great of boost performance, but it's very small feature detection. It's basically the inverse of finding black dots. It's finding white dots on a gray background. And so there's some advantages, disadvantages. So the short answer is, like, we're thinking about it. We have the out of the box, the version, a recalibration of, say, those is actually, we haven't found as advantageous as getting what Weiying asked for, which is getting the supervised training of YOLO V8 and V11 in first. So that's kind of where we're prioritizing. Let's get the supervised training first, and then maybe this ability to do a retrain of a foundational model in the future. But if you think that's a terrible route and we should do it the other way around, we'd be happy to hear that too and have that feedback. Yeah, go ahead, Gabriel.
Oh yeah. I have a feature request. slash ask if this is even in the scope of Thea, but I hope it is because I really want it. So more often than not, we'll run a model and we'll get most of the cavities, but not all of them. Is there any talk about adding a sort of interface to allow you to label just the few remaining, if that's the case after applying a model?
Yeah, that is absolutely in the works. That is very much a part of this program and this project with INL, is specifically to add that in. And then, as I mentioned, we have this other company that we've been working with because their annotation interface is amazing. And so we want to bring the best of everything that we can find and put that together. It's just a matter of trying to figure out, well, how do we get that integrated so that it's a fluid experience, so it's as easy as it has been to run the inference originally. But that would be part of it, right? Which is you upload an image, it doesn't get all the cavities, but at least it got 90% of them, and you would just want to go in then and be like, here's the last 10%. And now I can write my paper, give my presentation, right? Whatever it would be. And it's honestly just right now a matter of, well, how do we want that to look like, and how do we want that to function within that vision panel, and turning on some of the features that we actually have turned off when it comes to the graphical. I'm getting a little into the weeds when it comes to the programming here, but to our graphics library. Yeah.
Okay, thank you.
Yeah, and one thing I can envision that will be helpful with our platform, right, is that when you export, it exports as a ts.png, so it has all those label and JSON files. So I could see where maybe we don't have that version in yet, but you could re-import those data sets, those PNGs, and then label in a newer version when it comes out.
Okay.
So Kevin, Justin asked, would those hand-drawn labels be fed back into the model so it is potentially not missed in the future?
Yeah, so there's so the short answer is you'd have to retrain a model. The long answer is that there's a bunch of new or newer stuff that's coming out that we've been seeing, which is actually what this other company has integrated into their smart annotation tool that works really well. And so that's why instead of reinventing the wheel, we're just going to work with them directly and try to integrate some of that and then be able to do it and then do it. And so we have some ideas about basically, like, let's say you have a data on the microscope. You take the data, it annotates maybe 40% of the features that you want. You hand annotate the other ones while you're on the microscope or maybe that afternoon. And then the system would that night run a training update and then you'd have a fresh model the next day. Right. And so this kind of idea of this iteration and continually improving. The one thing that's nice about that in the machine learning concepts, or basically like in the data integrity concepts, is that we wouldn't purge or flush the old ones. So like if you wrote a paper in, now, and then did that work with a new iterative model that had been retraining every day for the next year, that you could still go back and look at the old way the data was processed and the new way, right? And so you have that as part of that. So it's a really long-winded answer to say, yes, we want to do that. That's part of this project that we have ongoing. And then we have this distinct advantage that you'll be able to go back to the old data and process it the old way or the new way, or the new model. Yeah.
I just answered it depends.
Yeah, that's the simple material science answer. Yeah. We'll know that the material science is rubbed off on you, Chris, if you answered as Gibbs free energy.
Oh, yeah.
Yeah. So, yeah, is there any...
or entropy, yeah.
Or entropy, yeah, exactly. Yeah. Thermodynamics.
The chemistry answer is hydrogen bonds.
Oh, yeah, and bio one's carbon bonds, right?
No, bio is disulfide bonds. Everything happens because of the disulfide bonds.
Right. Well, speaking of scientific blind spots, is there anything that you guys have seen at conferences or reading papers of interesting research that maybe we're not capturing, that we haven't seen, that would be exciting to you, or be a feature set that we could add into it. Actually, if you had a link for the paper and added it in the chat, that would be awesome. Or if there's something that you had seen at a conference that maybe is interesting. All right, we're at the cutting edge. It's good.
I can actually provide one.
Okay.
I'll ask you, Kevin. So can you control a microscope based off of the analysis that you receive on a Theoscope?
Not yet. Yeah, I think the number one requested feature is training, making it easier and more graphical user interface. I think number two is autonomous microscopy, right? So if you look at some of the stuff that Steve Spurgeon is doing and Sergey Kalin are doing, right? They're really pushing these ideas of an autonomous microscope as part of that. So we've been watching that. We have a short-term goal and we have a long-term goal, right? The short-term goal is, at least for the microscopists, the TEM people in the call, there's a specific software suite, the Gatan GMS, the microscopy suite, that is able to do minor controls of certain microscopes. And it tends to be the most uniformly used one across what we've run into for TEM users, because it does cross-platform between Joel and Thermo and so on as part of that. Their newest versions have a Python backend of GMS. And so we have been talking to them over the past year about how to integrate that. One of their engineers, Ben, which I can't remember his last name, I've actually visited, or he's visited here at Michigan, and we've talked to him a bunch of times. We have a framework for it. It's just getting the time to execute that past the training, right? So some of this is prioritization as part of that. So that's the near-term goal, is integrating and being able to say, move the stage based on what you see, or maybe zooming in or zooming out based on what you see, those types of things as part of that. And so we've fostered some of that relationship with Gatan. Long term, you're going to start talking about different microscopes, different specifics, different APIs. And that's just at a scale that is a long-term goal and probably won't be a feature that's coming out in the next year or two, unless we scale up significantly as part of that. But the Theoscope has all of the hardware capacity to do that, has GPIO ports, so analog digital outputs basically, and inputs, as well as talking with a couple companies that are doing new scan generators for STEM. We've talked to them as well. So we're putting the pieces of the puzzle together, but that's like a 1,000-piece puzzle or maybe a 1,000,000-piece puzzle. So it's going to take a while, right? So the first step is let's just get Gatan and communication working there. That also will be really nice for users that are on TEM systems that use Gatan, because we will have native porting of the images. So you won't have to do screen grab. It will directly send from the Gatan into the Theoscope as part of that. It's another reason that we want to get that integrated. And I know that TestScan also has the API with Python control as well. So for SEM users, that we prototype on Gatan and then probably we'll jump over to a TestScan, because I also have connections with an engineer in the UK that's for TestScan that would be interested in that. So we're kind of, we'll leapfrog to get to the final one as part of that. And to a certain extent, all right, this is a long-winded professor answer, right? To a certain extent is that the Joel system has already been figured out. So, Dr. Spurgeon and Dr. Kalin have kind of already built the Joel version of this for the TEM as part of that. And so if you're interested, use that system. It exists, and then the question is, do we just adapt or provide that, or go with a different one as part of that? So that's some of the decision points. So yeah, thanks, Chris, for the pitch for a long-winded answer on microscope control.
Yeah, we had Steve Spurgeon as a speaker last Friday.
Oh yeah.
Yeah, so suddenly, and he, as an undergraduate, took my thermo class. Small world.
Did you make him do a Gibbs free energy plot for you when he was here,
Oh,
just to
yes.
test this if he remembered your
Phase
thermo?
diagrams, Gibbs free energy plots. Yes.
Yeah, yeah.
The whole thing.
Yeah, so he's now at he was at PNNL. I'm
He's
drawing
at
a
NREL.
NREL.
NREL, yeah,
NREL.
Yeah.
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 Six months ago. Yeah. Small.
Small World, yeah. So Kip has another question.
It's a feature request.
Yeah, sorry, I
So,
kind of missed my chance.
oh no. What I can say is all of the annotation data like size, the particle measurements, sort of information, all of that is available in the export files if you do an export of an archive, and that's in the TS-PNG file. It's just in a JSON. And one of the things that we have, it is a feature request, I believe, already in the open source and freely available TS-PNG package, is to export information in the CSV format in addition to just dumping out the JSON in there. So it's currently not like one click and I get my CSV file, but it is all there, especially in the export all feature. It's just a little bit of a couple of steps. Now, we will totally add that in as a feature request to make it less steps and to make that as an alternative format. We have talked about other formats. So this would be a good question here from the open, like when Kevin was asking about features and that kind of thing, but also what other formats of images or data are people using that you would like to be able to see? We have DM4 support, we have TIFF file support, but are there other files out there that you want to see both as an output format, but also as an input format?
No. So
No,
I'm seeing everybody shake their head as part of it. Yeah. But Kip, I wanted to drive in a little bit on this.
Can I just interrupt? Is there, I don't know the format, but is it .mdb a format? It's like sometimes coming out of direct electron detectors. Which is a format that is such an pain to work.
This was actually going to be a question I had, is if you had any thoughts on using this for sort of the clunky, there's a really clunky aspect of analyzing 4D STEM data. And I think having something on the microscope with a GPU that can handle these larger data sets with some kind of image recognition would be very helpful. And you go to these conferences and all they talk about is 4D STEM, right?
Yeah. Kevin, do you have some comments about 4D STEM?
Yeah, I don't know if I want to share them. But the short answer is that's the first time we've had somebody ask. Right. The long answer in that is we'd have to go digging, because from my understanding on 4D STEM, there's two primary packages that people use for the data analysis. I can't remember the names of them off the top of my head.
and Pi4D STEM.
Yeah, Pi4D STEM, yeah. So the question there is adapting those or looking into those, and do they support those formats as a shortcut, right, to try to get things faster as part of that. So yeah, we haven't done a look to answer.
It was MDM or MDE. We thought the extension was MIB. Thank you. Yeah, I will investigate.
That would be truly helpful, because it's this converting from one format to another is eluded us for the time being.
Yeah. Is it supported in either of the two 4D STEM?
Recently,
softwares?
yes. Very recently, yes.
Okay. And you need you need the conversion because direct electrons exporting directly to drive, and then you have no visualization, or is it, where is the pain point, I guess, in using that data?
The pain point is in just even getting the MIB data. format to then go ahead and use as, say, the PyD stem.
Okay.
It's just being able to import, take this data and be able to import it in a sort of 4D stem analysis package that is open source.
Yeah. Okay. We'll take a look and see. Can't promise
like
we'll
it's
have something right away, right? But we'll take a look.
Sounds like a DM3, a DM2 file format kind of situation, right?
Yeah.
In that Matthew was saying that they just recently got support, so someone has cracked it. Maybe. I don't know. I can take a look. We'll throw it at some systems.
Yeah, don't take up too much time. This was just to
No, yeah.
you asked for another format, but there are all these 4D stem,
Yeah.
everybody with their formats.
Yeah.
Yeah. Coming back to Kip on your CSV request of export all, I'm just trying to think about how that would look the best for a user in a sense of, would you want, let's say you have 100 images and you want to export that data into basically a non-programmable data set, right? Which would be CSV, right? Or Excel or something like that. Would you want a separate CSV file for each image? Or would you want something that's like one file with every tab as part of that? Or export a CSV that's just the size, like say just the size column per image in that sense, like an average size. You see how like you could slice this, the data in so many ways? I'm curious like what would be the idealized approach?
My first thought was literally, just split it up, like maybe one big one with a sheet per frame, and or like how you do TSPNG where it's like a zip file of all of it, of one per thing, but like separated like that. But then again, if you have options, if you just want one thing, that would be a good, just give me size for every single thing. Like,
Yeah,
either of those.
So I could see almost something that you export say a master log, which is the column is each frame, right? And then it's say average size of each class, or say average number of each class in the image, and you have that per frame. So that's a really easy parsable CSV file. And then you have a separate zip that downloads with all of that data per image in it, so that then you have both, right?
Yeah.
Then you have the average per frame, and then you have all of the details per frame. I could see something like that.
Yeah, that'd be cool. JSON files are very intimidating.
Yeah. We don't have a way to, we have a way to export it for a single image through it, but not for the export all. So I could see having an export all to CSV.
That would be very nice.
Yeah. Well, I think we're about 2 minutes out from taking up an hour of your guys' Friday afternoons. So first off, thank you. We appreciate everybody's feedback and listening to us. But is there any last minute burning questions or requests from us? No? Awesome. Well, we will let you guys enjoy your Friday afternoon. It looks like it's beautiful there in Matthew. Like I'm just seeing the wind sweeping your hair is great. So hopefully you can enjoy the rest of the afternoon.
Thank you.
And if you guys have any more questions for us, feel free to do that. If you liked this would be great to know so that we can keep doing these in the future. We won't do them enough that you're doing them every Friday, like seminar that some of you have to go to, but enough that that we can update you on new features and new things as part of that. So thank you, and hope to hear from everybody soon.
Yeah, thank you.
Thanks.
Thank you, everyone. Have a great weekend.